Everyone, welcome to BYJU'S Exam Prep. Hope you guys are fine. So guys, are you all ready? Ready everybody? Because now we'll be starting the formula marathon. Come on guys. Faster, faster. Join soon. Okay. So I guess 1.5 hours it will take and we'll revise. Good evening, struggles. See, you told I just uploaded that. You were asking for the PDF now? Okay. So guys, come on, share with your friends. Imon, everybody. Hello, those Sai. Hello, everybody. Come on, guys, share it faster, faster, so that we can start. Before that, let me tell you. Fine, you can join my Telegram group. If you have any queries and as prediction series is going on, you can join that. Also, it has already been started. It's free, available in YouTube. It has already started from 21st of January. If you want to know what are the schedule of it, so it's been mentioned to you here. You can go through the schedule when and at what time which faculty will be taking it. Okay. Hello, Ayushi. Okay, and as you also know that Formula 1 series is also going on, which has also started from 21st of Jan, and this is the schedule for that. Okay, so that's it. And what next? Guys, if you're preparing for 2024, then if you are planning to score under 100, what are the factors which guarantee you rank under 100? This session will be live on 24th of Jan at 7:30 p.m. Okay, so guys, this I have to tell you before we move that वर्बल एबिलिटी आई नो इंग्लिश को सब हल्के में ले लेते हैं यार, बन जाएगा, जो बनना होगा ना वो तभी बनता है, पहले से नहीं बनता ऐसे. दिस इज अ प्री कंसेप्शन, बिकॉज आप इंजीनियर हो तो मैं भी तो इंजीनियर हूँ, तो यार जो बनना होगा ना बन जाएगा. इंग्लिश के लिए टाइम नहीं देंगे बिकॉज यू हैव दैट प्री कंसेप्शन इन योर माइंड. 5 मार्क्स का आता है और हर एक मार्क्स डिसाइडिंग फैक्टर होता है. ओके, सो यू कांट डेयर टू मिस इवन अ सिंगल मार्क. सो यू हैव टू बी प्रेजेंट विथ मी ऑन 27th January, okay, for verbal ability. Similarly for engineering, maths 28, general aptitude 29. Match you, Arun. Okay, and guys, if you are preparing for ESE, starts from 13th of Feb on YouTube. You can join the non-tech marathon. And Arun, Sai, Struggle, Imon, to everybody, let me tell you, guys, our paper is on 12th of February. 4th is for mechanical. So we will be having the live examination analysis. So isn't it amazing? So be ready for that, guys. Still, if you haven't subscribed the channel, do so, because we'll be coming live with all the questions, all the solutions on 12th Feb for civil engineering. Okay, guys, last but not the least, GATE preparation ebook link is in the description. Now, before we move to the formula marathon, everybody ready? Ready everybody with high Josh. It's 10:30 around. We'll try that we'll complete it in 1.5 hours. Only formulas. Ready everybody? I want the answers. A heart sign or ready sign in the comment section. Come on, Ayushi, everybody. Faster, faster. Till then, let me tell you the topics which you cannot miss is quality parameters of water, suspended solids, hardness, alkalinity, MPN. And if you talk about treatment of water, sedimentation, filtration, disinfection. Okay, ready. Okay, then distribution system, pipe appearances. However, the chances are less, but they can ask you in MSQs and all. Next, coming further is you have quality parameters of sewage, in that BOD, COD, THOD. Okay, design of sewers, partial flow and full flow conditions. Disposal of sewage effluent Streeter-Phillips equation. I know it has that equation is a lengthy, but they can ask you from that. Okay, treatment of sewage, if you talk about activated / trickling filter, oxidation pond, and air pollution, types of pollutants, plume, and in solid waste, disposal methods. Clear? So I have told you all the important topics also of the environmental engineering, which you have to do it. Okay, I bifurcated chapter and then the bifurcation of the topic also have done it for you guys. Okay, now coming further, as you know, when you go to water demand, let me take white color. Okay, As you know, we go for water demand to know the demand of the people, not for the present, but we design it for certain years. So I have already told you, if P is the population and let us suppose X is per person's per day demand, that is LPCD, liters per capita per day, per person per day requires how much amount of water, then we have two methods. One is maximum daily demand, which is equal to 1.8 times annual average daily demand. What do you mean by annual average daily demand? It means P population को पूरे साल में कितने पानी की requirement होगी, okay, on an average basis. So how much water does P population requires on average basis for the whole year? Is it सही बोला कि गलत बोला? देखो तीन चीजें होती है फास्टली, तीन चीजें होती है. पहला होता है एनुअल, जो अभी मैंने बोला एनुअल, एनुअल ड्राफ्ट या एनुअल डिमांड. एनुअल ड्राफ्ट इज टोटल क्वांटिटी ऑफ वाटर रिक्वायर्ड बाय पी पॉपुलेशन, एंड इफ इट इज एनुअल एवरेज एनुअल ड्राफ्ट देन एनुअल एवरेज डेली डिमांड. दिस टोटल पॉपुलेशन को 365 डेज में अगर V वॉल्यूम ऑफ वाटर रिक्वायर्ड है तो एक दिन में कितना होगा, विच इज एनुअल एवरेज डेली डिमांड. डेली मीन्स एक दिन का, विच विल बी हाउ मच, V अपॉन 365. फिर होता है एनुअल एवरेज पर कैपिटा डेली डिमांड, दैट इज पर पर्सन पर डे रिक्वायर्स हाउ मच अमाउंट ऑफ वाटर, so that is annual average per capita daily demand, which is V upon 365 into P, because this was for P population, and if you want for 1, divide by the total population. Clear? So this was maximum daily demand, 1.8 times annual average daily demand. Then you have maximum hourly demand. Maximum daily demand, let us suppose it is maximum on, आज कौन सी date है, 23rd January. So 23rd January, there will be 1 hour where will the demand will be maximum. Okay, so maximum hourly demand of maximum day. 23rd January का भी 1 hour होगा जब demand सबसे ज्यादा होगी. That's why maximum hourly demand of maximum day. This will be how much? 1.5 into two formulas are there. One is 2.7 into annual average hourly demand. And another formula is 1.5 times into average hourly demand of maximum day. Clear? यहाँ तो कोई डाउट तो नहीं हो रहा, स्पीड सही है? Let me know this faster. Speed is okay till here, guys. Faster. Let me know this, then only I'll proceed. और अगर और बकअप करना तो वो भी बताओ मुझे. Come on, guys. Faster, faster, faster. Okay. Increase. Sure. Fine. Then we'll come to fire demand. Fire demand, we have different methods. That is Kuchling's formula. All these are empirical. That means denotion along with the units is very much important. Q is equal to 3182 root P, where P is the population in thousands, Q is the discharge in liters per minute. Prevan's formula, let me tell you, in different books you will get different things. In some books you will get 1135.5 P by 5 plus 10. Sometimes you will get P 10 plus 10. It is totally observation based. Generally we take it 1136 P by 10 plus 10. Okay, in every formula of fire demand, P population is in thousands, discharge is in liters per minute. Example, if the population is 2 lakhs, you will write it here 200. Okay, next, National Board of Underwriters formula. This you can apply when the population is less than 2 lakhs. And the formula is 4637 root P 1 minus 0.01 root 3. Okay. After this, this I have already told you. After this, talking about distribution system. Distribution system, when you design, it will be maximum of MDD plus fire demand or MHD. MDD plus fire demand is known as coincident draft. So it's not necessary every time they will ask you what is the design draft for distribution system. They can only directly ask, tell us the coincident draft. Okay. Next, coming to the population forecasting methods. Okay, because if we design it for today, it's obvious that it will fail the next year, because you know, as you know guys, that we have Bustons छूट गया क्या? चलो Bustons ही बता देते. Bustons formula 5663 root p. This is Bustons formula. Okay, as you guys know that we have crossed China and now we are biggest in population. So if we design it for today's, obviously in the next year the systems, pipe apprentices, everything will fail for sure. That's why we design it for certain years, and for that reason we have to forecast, predict, अनुमान लगाना पड़ता है किसका? Population का. So we have to do that. So first is the arithmetic increase method. Everywhere PNS, population after n decades. P naught is the last known population. X bar is average increase in population. Sometimes MSQ is there on 5 demands of 3 months. Yeah, that's what I was telling Tiksha. Sometimes they write P by 5, but generally if you will see 1135.5, P by 5 plus 10 they use. Okay, so that when it is 1135.5, then generally we go for P by 5. When it is 1136, we go for P by 10 plus 10. Okay, X bar is average increase in population, N is number of decades. So now this is used for old cities, and we assume while arithmetic increase method is there, one thing which is most important I'll tell you, that generally it's not necessary that they will tell you calculate the population forecasting by arithmetic increase method. They can say assume rate of growth of population with respect to time is constant. If they say like that, automatically your mind should go that it is talking about arithmetic increase method. Everything in the examination will not be spoon fed to you. Okay, because this is the basic assumptions. dp by dt is constant. Then we have geometric increase method, in which the assumption is rate of growth of population with respect to time is constant. Okay, so this we use for young city, or you can say rapidly growing city. This is the formula. Here R I have taken it in percentage. In books you find it like this also. So in that case they take it in terms of decimal. Right now I have taken in terms of percentage. Okay, now if you want to calculate R, that is percentage rate of growth, there are various methods. Now when to use what? Generally if nothing is given, then you have to go for geometric mean method. This is being given and this is recommended by the court. Geometric mean method, remember. So this, don't get confused. Geometric increase, arithmetic increase is different. Geometric mean method is the method for calculating percentage rate of growth. Arithmetic mean method, because they can ask you, arithmetic mean method is also a method for calculation of percentage rate of growth. True. The value of percentage rate of growth by arithmetic mean method is more as compared to geometric mean method. True. Third, as per codal provisions, geometric mean method is recommended for calculating percentage rate of growth. True. So right now in front of you, I made three concepts. I made three, you can say, statement-wise questions for your MSQ. Okay, so you have to be aware. This is geometric mean method for calculating percentage rate of growth. This is arithmetic. This is geometric. If nothing is given, you will go for this. Otherwise, if only two data is given, P1 and P2, two populations are given, and it is asking you to calculate percentage rate of growth, you can go for this. Okay, R not constant in incremental. We don't talk about R. Rishabh Pant better. Aditya, ऐसा मत बोलो यार. I got formula for talking. Watch my lectures, Aditya, won't forget. Rishabh Pant is an all-rounder, Aditya. He attends my lectures and he goes to play cricket also. Okay. So I'm a die-hard fan of him. So don't say anything. Okay. Fine. Okay, Rishabh? Okay. Okay, n is the number of rates. N is the number of rates. Rates, you can say if 2R is there, 2 you will take. If 4R is there, 4 you will take. Okay. Next, coming to incremental increase method. This gives you moderate value of population forecasting. Arey Aditya, I was kidding, bro. Don't get tensed. चलता है ना अपने बीच तो. We are engineers and that too civil. Incremental increase method. Here we give moderate value of population forecasting. We get geometric method. We get high value of population forecasting, while in the case of arithmetic we get low value of population forecasting. Okay, x bar average increase in population, y bar incremental increase. जो increase हुआ है उसमें कितना increase हुआ है. So it is average of incremental increase. Then this is the formula for decrease growth rate method. Decrease growth rate method का method ये बिल्कुल नहीं होता है guys कि population कम हो रही है, population is decreasing. I am telling it bilingually in both the languages right now, so that अगर किसी को English नहीं बनती है तो बीच में connect कर पाए. See, population is increasing, but the rate at which it is increasing is decreasing. Like if I say, Arnav is what he eats. I give this example, 5 chapatis. Then his diet increased to 10 chapatis. Then his diet increased to 12 chapatis. So initially the percentage increase was 50%. Now the percentage increase is how much? 2 by 10 into 100. Again 50% it is coming over. I will write 11. So 1 by 10 into 100, 10%. So the diet is increasing, but the percentage by which his diet is increasing is decreasing. Similarly, population बढ़ रहा है, but percentage घट रहा है. So that is decrease growth rate method. Okay, incremental rate is decreasing. Increment rate, correct. Okay. Okay. Now coming back again, decrease rate of growth method. This is the formula, but I will personally tell you जो मैंने आपको बताया है. What I have told you in the marathon class. ये तो formula marathon है. When I took a complete marathon class, there I told you a shortcut. So that will be better because इतने formulas है civil में. If you'll go, I don't think this is desirable. So if you want, this is the formula. R, N, everything is same as I have discussed right. Okay, you can go for this, but remember one thing. In previous, let us suppose अगर 2000 का population given था, 2020 का बोला था, तो n is equal to 2 लेके you have solved it, but not in the case of this decrease rate of growth method. If it has asked you for 2020, then also you have to calculate 2010. Okay, so make sure of this. Then logistic curve method, guys. I want the answer in comment section when you can use this logistic curve method. I won't teach you. You will be telling me there is a statutory warning. जैसे पिक्चर देखने जाते तो बोलते हैं ना, तंबाकू सेवन, गुटखा सेवन हानिकारक है. Smoking is injurious to health. All these things they write it. That is statutory warning. So logistic curve method also you can apply when? Tell me, एक warning आती है, कब apply कर सकते हो? Tell me fast. Come on guys, I want the answer. Tiksha, Arun, everybody. अब पिटाई होगी. T2 is twice of T1. All calculations are done from base here. At T0, at T is equal to T0, P is P0. At T is equal to T1, P is P1. Remember? यार तुम लोग मेरे से पूरा वो पढ़वा रहे हो. एग्जाम्पल 1990, 2010, 2050. Can you apply here? Can you apply here? Tell me the answer. Rishabh, everybody. Can you apply here? Logistic curve. Can you apply here? Yes or no? No. Why? Because from here it's 2 decades. From here it is 4. But We calculate from here, it is how much? 6. So you cannot apply because 6 is 2 into 3. While here, T1 is 2 decades. T2 is 4 decades. So T2 is twice of T1. So here you can apply logistic curve. So you guys, you have to check it first. Then if you want to calculate the population, forecast the population, then this is the formula PS 1 plus M e to the power NT. PS is the saturation population. You have to remember the formula. M is PS minus P naught divided by P naught. Okay, इसमें एक mistake होती है. Generally we have the habit of initial minus final upon initial. ये generally we do it in mathematics and everywhere. So in a hurry, you guys do PS minus P naught divided by PS, which is wrong because PS minus P naught divided by P naught it will be there. I also make this mistakes. So कुछ लोग क्या होता है, some people are like कि वो दूसरों की गलतियों से सीख लेते हैं, and some people are like जब तक खुद गलतियां नहीं करते तब तक नहीं सीखते. So I am the second category person, but I don't want you to be the second category person, okay? Because life is not so big कि सब गलतियां खुद करो, कभी कभी दूसरों की गलतियों से भी सीख लिया करो. So that's what I wanted to say. I generally do this mistake, so I'm telling you don't do this mistake. Logistic curve तो कभी गेट में पूछा नहीं है, तो be the change you want to see in the world. अगर पूछ लिया तो फिर बोलोगे मैम आपने तो कभी पढ़ाया नहीं. फिर like mechanical last year there were certain questions which were asked which were never asked. तो बच्चे बौखला गए. अब कल को पूछ लिया फिर तुम एक को ही बोलोगे. तो मैं तो सेफ प्रिकॉशन लूंगी ना कि भाई साहब हम पूरा पढ़ा देंगे आपको. तो that's it. n is equal to 2.3 T1 अगर इसमें पूछेगा तो T is equal to T1 is equal to 2 लेके चलोगे. log base 10 P naught initial population PS saturation population P1 P2 जो भी है corresponding you have to take it. Okay, next talking about quality parameters of water. इससे बस हमें quickly नाम जानने हैं. हाँ, tell me one question I'll ask. Out of the 4 methods given to you, which of the following is a field method for measuring turbidity? I don't want you to write the full one. A, B, C, D. Tell me. A, B, C, D. Which one is used? Tell me fast. Which is the field method? Correct. Correct, Yathishi. A, that is the turbidity rod is a field method. Okay. Out of that, हाँ, इसमें कुछ चीजें याद रख लो, जैसे कि प्लैटिनम क्या यूज होता है? प्लैटिनम नीडल. Correct. So these things you should know. Okay. Aluminium rod, platinum needle. Correct. So these things you should know. Jackson's turbidity meter. अब ये पूछ ले, ये ऐसे डायरेक्टली नहीं पूछेंगे, ये पूछ लेंगे. For measuring turbidity of water bodies, which of the turbidity meter is used? So Jackson's turbidity meter is used. Bailey's turbidity meter, color matching technique. Nephelometers, which is the one which is used on latest basis? So that is nephelometers. Why they are used on latest basis? Because instead of silica dioxide, they use formazine, which gives more better result as compared to silica dioxide. And moreover, it is based on scattering principle. And a photometer. Photometer is a semiconductor device which produces current when light is incident on it. So what happens is when you talk about nephelometers, it measures the scattering light, to be precise, the light scattered at 90 degrees. So it is based on current matching technique. A standard sample, for the preparation of standard sample, formazine is used, which gives accurate results and it can measure turbidity even less than 1 unit. Clear? 1 mm lines, 25 mm. Yo, bro. Correct. Okay. Then talking about colors, we have tintometers for that. If 1 mg of platinum cobalt in the form of chloroplatinate ion is dissolved in 1 liter of distilled water, the color which will be imparted, we will call it as 1 TC. Again, an important thing. It imparts generally yellowish color. Now you will say, ma'am, zaruri thodi na hai ki yellowy color hoga. हमने थोड़ी ना बस yellow color देखा है. There are many colors which is possible, I know. दैट इज द रीजन. अगर देखो कुछ चीजें जो पढ़ते चले आ रहे हैं पर अपडेशन हुआ, तो अपडेशन कौन बताएगा? मैं बताऊंगी. कहाँ बताऊंगी? बायजूस एग्जाम प्रेप में बताऊंगी. तो color, if you want to see, spectrophotometer technique, which is the latest techniques which is being used for the measurement of colors. These names you should know it. Okay, taste and color, osmoscope. Osmoscope में क्या होता है? वो ऐसे स्मेल करने का रहता है. Different dilutions. 200 ml as per code is fixed. A plus B should be 200 ml. Now, ma'am, what is A plus B? A is the volume of raw water and B is the volume of distilled water. So I will add various permutation and combinations of raw water and distilled water in such a manner that the total volume become 200 ml. अब मैंने तुम में से 10 लोगों को बुलाया. अब तुम 10 में से 10 sets of noses, अगर कोड पढ़ोगे उसमें लिखा आता है 10 sets of noses. So I'll call you and 10 people and I'll say smell करो. कुछ smell आ रही है. 9 people have said no. But even if one person like Siksha says that ma'am smell is coming, I will say no, rejected. Again I will do different dilutions. Okay, so taste and odor, this is based on taste and odor are two different things, but हमें eventually पता चला जो taste देता है वो odor देता है, जो odor देता है वो taste देता है. Like when your mother cooks, you are like मम्मी अच्छी स्मेल आ रही है, क्या बना रहे हो? फिर मुंह में अपने आप ही स्वाद आने लगता है. So similar thing goes here. Practical, nothing हवा में कोई बातें नहीं, सब चीजें practical है. So taste and odor, we have threshold odor number which we call it as TON, which is volume of raw water plus volume of distilled water divided by volume of raw water. Okay, then you have temperature, final volume of diluted sample upon initial volume of test sample. You can call that also. Temperature 10 to 25 degrees Celsius, which is generally desirable. Okay, then you have chemical parameters. Chemical parameters, you know, total solids, which is the you can say it is suspended solids and dissolved solids. Total solids, if you want to calculate, कोई दिमाग नहीं लगाना है. Sample लो, suspended भी होंगे, dissolved भी होंगे. Heat it. 104 degrees Celsius, 24 hours, heat it. What will happen? You just calculate the weight. Let us suppose it is coming x mg. So x mg per liter is the value of suspended solids. Concentration to be precise. If you want to calculate suspended solids, total solids is there. Pass it through a filter paper, layman's language. Okay, here suspended solids will be there. 104 degrees Celsius for 24 hours. Let us suppose it comes out the weight y. So you will say Ymg per liter will be suspended solids. जो बचा हुआ गया वो dissolved solids. Heated at 104 degrees Celsius for 24 hours. You will get it. Let us suppose Z is the value. Zmg per liter. Now, अब एक सच्चाई बताती हूँ. बस जानकारी के लिए, इसका पेपर में यूज नहीं करना. 100% suspended solids ऊपर retain हो जाए, ये possible नहीं. It's not possible that 100% of the suspended solids get retained. 100% of the dissolved solids is there, that is also not possible. Okay, example I have already told you. जब आप चाय को जब आप छानते हो, okay, you do it, you sieve it. Okay, so along with tea leaves, there are certain quantity of water which is soaked in the tea leaves. So you press it with spoon. We Indians do that, and you are proud of it. Yes or no, guys? So that's the thing. That's where I prove my point. Okay. Then coming to pH. pH is minus log base 10 H plus ion. H is one important thing. It will be in moles per liter. This is the important thing. pOH, again moles per liter. This is one relation. pH plus pOH is equal to 14. H plus into OH minus is equal to 10 raised to power minus 14. This time it will become moles per liter square. Okay. Then coming about hardness. Hardness देखो ये को दर्शक करो. Hardness पानी में हमेशा every single time it will be due to the presence of multivalent cations. Cations are positively charged ions and those ions which have a valency more than one. What is valency, ma'am? Valency is the combining power of an element. Like if NaCl is there, Na will give one electron to chloride, it will become positive. Chloride will take one electron, it will become negative. So the valency comes out to be 1. Similarly, so hardness is always it is due to the presence of multivalent cations. Now coming, मैं बोर नहीं हो जाती. तुम जैसे लोग सब लोग मुझे मोटिवेट करते, मैं बिल्कुल बोर नहीं होती. मुझे प्यार है सब्जेक्ट से. Okay. Then hardness, we have further bifurcation: carbonate hardness, non-carbonate hardness. Carbonate hardness, you call it temporary because simple boiling, addition of line, it is getting removed. Non-carbonate hardness is something आसानी से नहीं जाएगा. You have to add, you have to give special treatment like zeolite method, demineralization process and all. Total hardness is the summation of carbonate hardness plus non-carbonate hardness. Carbonate hardness, if you want to calculate, it will be minimum of total hardness and alkalinity. If total hardness comes out to be less than alkalinity, then non-carbonate hardness will become 0. So remember that. Sodium alkalinity is, we drink water. Sodium due to, let me tell you, Rishabh, there is no alkalinity. You are seeing sodium, NaOH. Sodium alkalinity is due to OH minus ion. If you're talking about alkalinity, it is due to OH minus ion. Caustic alkalinity, you call it. Clear? However, if you talk about hardness, there is a term like pseudo hardness, जो असली में कुछ है ही नहीं, बस हमें बना दिया तो पढ़ रहे हैं. जो ions, those ions which does not impart hardness, they impart pseudo hardness, like Na plus ion, K plus ion. Okay. Now, talking about hardness, this is the shortcut method, or you can go by gram equivalence concept. Generally, quotient में concentration of calcium in mg per liter into equivalent weight of calcium carbonate divided by equivalent weight of calcium. You have to do this and you will get the answer. If in the examination they have given you any other multivalent cation and they haven't written to ignore it, then you have to consider it. Equivalent weight of calcium carbonate, equivalent weight of aluminum. Don't worry, atomic weights will be mentioned. One more thing very important, milli-equivalents per liter. If they write and give you this value, that means they have given you, let us suppose, concentration of calcium. अगर उन्होंने milli-equivalents per liter of calcium दिया, if they have given like this, so it will be concentration of calcium divided by equivalent weight of calcium. This means milli-equivalents. So you don't need to divide it by the equivalent weight of calcium. You just multiply with the equivalent weight of calcium carbonate. That's it. So just see in the question whether it is given mg per liter or it is given milli-equivalents per liter. Okay. Similarly, if you want to calculate alkalinity, alkalinity in water is due to, or basically you can say alkalinity means what? Alkalinity means now ability of water to neutralize acids. अब पानी में ये एबिलिटी आती कैसी है? फ्रॉम वेयर डज दिस एबिलिटी कम्स इन वाटर? इट कम्स ड्यू टू द एनायंस. इफ alkalinity is due to bicarbonate ions, bicarbonate alkalinity, carbonate ions, carbonate alkalinity, OH minus ions, caustic alkalinity. One more thing, some places they subtract minus H plus ion. अगर इसको subtract करोगे, there is hardly any change. But if in the question in GATE examination it comes, then you have to consider it. If any other cations comes, multivalent cations, if it comes anakha, then you have to add it. Okay, or if it is not mentioned in the question, ignore the effect, then you have to consider it. Multivalent cations. Okay, this is the table. 25 here. Okay, this is the table. You have to consider it 5 or 25 hai na? So this is the table of permissible limit, that is acceptable limit, and cause for rejection limit, which you have to consider. Okay, guys, hardness and alkalinity, same it is there. Fluoride you already know. Fluoride you know that it is a बहुत ही notorious element है. Why it is? कम हो तो भी दिक्कत, ज्यादा हो तो भी दिक्कत. Up to 1 ppm it is good. It prevents from dental cavities, helps in permanent growth of teeth. Above 1.5 ppm, modeling of teeth, decolorization, that is fluorosis. Beyond 5 ppm, deformation of bones, bone fluorosis takes place. Okay, so it has a very short range. Next, coming further, nitrogen content. 4 ways: free ammonia, organic ammonia, which you call it as albuminoid now also. Okay, albuminoid nitrogen also. So remember the other name. Free ammonia plus organic ammonia will give you, or you can say free nitrogen plus organic nitrogen will give you K-Jalal nitrogen. Then you have nitrite, then nitrate. Nitrate, if you know, 45 mg per liter more, it will lead to methhemoglobomania, which is known as blue baby disease. If you talk about nitrate, nil. You cannot and cannot allow even a single drop of water in nitrite, because in that organic matter is there. And if organic matter is there, हमेशा याद रखना मेरी एक बात, वो मैंने गाना बताया था ना, जहां मैं जाती हूँ वही चले आते हो, दैट्स द थिंग. जहां जहां ऑर्गेनिक मैटर, वहां वहां माइक्रो ऑर्गेनिज्म. Wherever organic matter, there will be microorganisms. So in nitrite, partial decomposition of organic matter is there. That means still decomposition is going on. And if decomposition is going on, that means microorganisms. Okay. Okay. Next coming further. MPN, you have tests like presumptive test, confirmative test, completed test. In presumptive test, first when you take it, you get it lactose growth. Lactose growth, हाँ ये values change हो गए, दोनों को मिला के up to 0.45 है. NH3 0.3 values change ना, दोनों को मिलाकर change हुई है. ये previous codal provisions है which is being followed. But you will tell me first in the comment section what is the new values. Then I will also tell you in the comment section. ओके. एमपीएल सच बता रही हूँ, ये टेस्ट ऑब्सोलेट हो चुका है. प्रैक्टिकली फील्ड में जाओगे, यू विल नेवर एवर गेट दिस टेस्ट, बट इट इज बीइंग यूज्ड, सो वी आर आल्सो, बिकॉज इट इज आस्क्ड इन द एग्जामिनेशन, दैट्स व्हाई. Presumptive test, lactose broth, you will add it and you will see if gases are coming. Presumptive. Confirmative test, जो positive gases वाले test tubes है उनको पकड़ो, उसमें lactose green bile broth डाल दो. If gases are coming, then completed test मतलब present है भाई. अगर till now they haven't asked a single question by this formula which I have given you. This, if table is not given to you, then this is the one which you will use. Thomas equation बोलते हैं इसको. Number of positive tubes divided by volume of sample in negative tubes into volume of sample in all tubes. Always remember, table which will be given for you in the MPN is 10, 1 ml, 0.1 ml. Ma'am, why? Because every time whenever testing is done by the code, they have done for this dilution. Okay. अगर ज्यादा की आती है, then you can multiply कितने गुना dilution हुआ, the number of times it is diluted, you have to multiply by that. Let us suppose, example I'll tell you. You have taken a sample of 0.1 ml, 0.01 ml, 0.001 ml. Here also 3 to 1 is there, here also 3 to 1 is there. Table for this MPN will come out to be, let us suppose 40. This is arbitrary value. Now you see this sample is 100 times diluted. So 40 into 100. Remember this. Okay? This you have to make sure. Now, coming further, membrane filter technique. As you all know, basically testing of pathogens is tedious, time consuming and costly. So instead of testing pathogens, we go for testing of coliforms. Coliforms presence or absence indicates the presence or absence of pathogens. So in membrane filter technique, what you do, you pass it first through a membrane, so that what will happen, only pathogens and coliforms are there. Then you put it in an incubator and you add a food known as M endomedium. This is the food only for coliforms. So those will get the tubes. They will do what? They will become multiples in numbers, and pathogens will not get the food, so they will die. So at the end, we will count the number of colonies which will give us the pathogens. Ma'am, but we counted the colonies of E. coli. How we will get pathogens? Because we will do calibration. Two unknown चीजों को relate करना, that is calibration. Okay, into 100 नहीं लिखा था क्या? Into 100 is also there. Green background is best. Fine. Number of positive tubes. Thomas equation का. Let us suppose 10 ml, 1 ml, 0.1 ml, 0.01 ml is there. Okay. 3, 2, 1, 4. Fine. Next time in the irrigation one, Arun, I will do green. Okay. 2, 3, 4, 1. This is positive. This is negative. So how many positive is coming? 3 plus 2, 5, 5, 5, 10. Number of positive tubes, 10. Here I am doing by Thomas equation. Crazy boy. Okay. ml of sample in negative tubes. 2 is there with 10 ml. 3 sample is there with 1 ml. 4 is there with 0.1 ml. 1 is there with 0.01 ml. This is the ml of sample in negative tubes. Into ml of sample in all tubes. Total करोगे 5 ही tubes होंगे every time. So 5 into 10 plus 1 plus 0.1 plus 0.01. So this will give us the MPN per 100. Clear? Engineer G, clear? So this is the MPN per 100 ml. Okay. Now moving towards treatment of water. Treatment of water, you know. First we go for screening. Screening is done for the removal of large floating matter, and you calculate head loss by the formula K by 2G V square minus U square, where V is the velocity through the screen, U is the velocity of approach or velocity above the screen. Generally, we go for coarse screens, not for fine screens, because in fine screens, frequent choking and head loss are more. Okay, K by 2G 0.0729 if not given in the question. K depends upon the material of the screen. Coming back is to the sedimentation. Sedimentation, you know, there is plain sedimentation, there is coagulation aided sedimentation. The hero of the sedimentation is specific gravity. Here you have two types. One is quiescent type and another one is continuous flow type. Quiescent type you call it as fixed type, you call it as fill and draw type. Now what you do, kuch nahi karna, dimag nahi, lao, pani rakho, this, what do you call it, turbulence, made it 0. So it is based on maximum daily demand. The period is 24 hours is the detention time. Okay, and minimum number of tanks required will be 3. Okay, because one we have to keep it for standby. Continuous flow type tank, you don't make the turbidity 0. The flow is taking place, but in such a manner that the water is flowing, the suspended solids is settling, flowing, settling, flowing, settling, so that it settles, and by the time it reaches to the end of the tank, the suspended particle has already been settled. Okay, so that is continuous flow type. Now there are various flows, laminar, transitional, turbulent. Size is given to you. One important thing. Sometimes it might be possible that in the case of examination, the dia is more than 0.1 mm. But if it is telling you assume laminar flow and assume Stokes law to be valid, then apply this formula. Ma'am, but you told dia should be less than 0.1 mm. That I agree. But in the question, it is deliberately telling you to apply the formula, then you have to do it. Okay. And if it comes, consider like question generally we give in a test series and all, assume the flow to be transitional or assume the flow to be laminar and consider the effect of temperature. If they write like this, you go by this formula. Remember, this is empirical in nature. You will get it. This settling velocity is in mm per second. Dia is in mm. Temperature is in degree Celsius. Okay. So this you have to remember it. This दोनों दिखने में same लगता है, जुड़वा जुड़वा, चंटू मंटू, but it's not same. Why? Because here d square is there, here d is there. Other than that, everything is same. The units and all it is same. Okay. So that's it. Turbulent. This formula you have to apply. Nu is here. This is nu. Nu is kinematic viscosity, which is mu by rho. Okay. Then surface overflow rate is the velocity of the concerned size of particle or velocity of the design size of particle. Remember, other sizes के particles के लिए, अलग-अलग sizes के particles के लिए you can apply this formula for settling velocity. But for that particle for which you have designed the tank, for that if you want to calculate, you will go by this formula. Remember BL, sometimes they write this as plan area. So B into L is the plan area. Remember. Okay. And B into F is the cross section area. And if they ask you percentage removal, VS by V naught into 100. Okay. Now, this formula I've seen maximum students, you guys make mistake. I don't know, decimal points में, zeros में गलतियां हो जाती है. Volume of circular tank is D square 0.785 H plus 0.011 D. This is the formula for volume of circular tank. Then coagulants, generally अभी तक जो question पूछा, they have asked for alum. Alum Al2SO4 thrice dot 18H2O. One more thing, in coagulants, at least you should know the 4 mechanisms, that is ionic layer compression, adsorption and charge neutralization, sweep coagulation, interparticle bridging. Okay, and calcium bicarbonate. Alum में bicarbonate दोगे नहीं, ये function ही नहीं करेगा. It will not at all function. Okay, so if it is not there, you have to deliberately add it. And if how to add calcium bicarbonate? By adding calcium carbonate. How to add calcium carbonate? By adding quicklime, that is calcium oxide. ओके ये मैंने शॉर्टकट बना दिया था सो दैट यू हैव ऑलरेडी सीन हाउ रैपिडली द क्वेश्चन कम्स. कॉपरस कॉपरस के ऊपर मैंने क्वेश्चन ऑलरेडी अभी लास्ट ऑन मंडे yesterday only I have given a question on this one कॉपरस. पूछा नहीं गया but I have given you the question on it in the expected series one. Volume of circular tank pi r square h. In some cases, crocodile Z, they don't give you this and they ask you the diameter. In that case, you can go by this discharge area into velocity and discharge by velocity pi by 4d square. Because in GATE they have asked some questions where they have not given. देखो समय समय की बात है, data की बात है. If they are giving you height and all and it has told you volume of circular tank, you will go by this. But if you see the GATE questions, generally they are like discharge by velocity and from here you get the dia. Okay? Fine. Now coming to मिक्सिंग बेसिल केमिकल डाला है मिक्स भी तो प्रॉपर्ली होना चाहिए ना. व्हेन यू ऐड अ केमिकल दैट इज द कोवेलेंट इट शुड गेट मिक्स्ड आल्सो. सो द पावर रिक्वायर्ड विल बी g square mu v. G is temporal mean velocity gradient which will tell you the intensity of mixing. V is the volume and the most important thing is अब MSQ में पूछ लिया then good. What is that? G value more and smaller value of detention time, small and dense block. Small g and larger TD, large and light. Okay, this you should remember it. This. Now coming to filtration, I am just telling you the formula, guys. Okay, पूरी theory तो हमने 9 hours, how many minutes we have already done that. So 9 hours 56 minutes if I'm not wrong. So we have done the whole theory, but right now we are revising only the formulas. Filtration, if you talk about filtration, we have slow sand filter, rapid sand filter. Generally questions still now have been asked for rapid sand filters. So when you give backwashing, okay, the filter bed expands. So the expanded porosity is given by the formula Vb by Vs to the power 0.22. Vb is the backwash velocity, Vs is the settling velocity. One thing, in the case of rapid sand filter, the settling velocity is laminar in nature. So this is the formula which you need to remember. Okay, this is important. Can you explain it maximum last points? What do you want me to explain, MVS? What do you want me to explain? Tell me. Detention time means कितने समय के लिए पानी टैंक में रहा. ठीक है. If intensity of mixing is more, but you have provided a lesser time. जो flocks बनते हैं, flocks. Okay, that will be very small, but density will be more. Denseness ज़्यादा होगी, मतलब छोटे होंगे but भारी होंगे. When it is small, intensity of mixing, mean velocity gradient, if you have provided very small, okay, but detention time ज़्यादा, so होंगे वो हल्के फुल्के, but उनकी quantity ज़्यादा होगी. Okay. Fine. Now talking about chlorination. Chlorination, you know, chlorine will function when pH is more than 5. Otherwise, it will not function only. So, this is the one. This is the reaction which you need to remember it. When HOCl and hypochlorous acid and hypochlorite ion is formed, you know hypochlorous acid is 80 times more powerful, more destructive as compared to hypochlorite ion. Why we use chlorine only? Because it safeguards against present and prevents future recontamination. Okay? Then Fick's law. Guys, पता नहीं क्यों क्या प्यार है, हर साल ये पूछ लेता है. So you need to remember this. Nt is equal to N0 e to the power minus Kt. T is equal to 1 by K. This, if you solve it, it will come out to be this. Then they ask you percentage, you can say percentage killing, percentage efficiency. So this will be N0 minus Nt divided by N0 into 100. Okay. Similarly, there is one more formula. If you want same, till now they haven't asked, but I am telling you, if you want same percentage of killing and you have changed the temperature, so how much time will be required? So this is the formula. Okay, but it has not been asked till now, but the temperature has to be in Kelvin. Okay. Watson's law. This is the Watson's law. Correct? And we just generally not been given in the examination, we take it as 1. for same degree of disinfection. Okay. Then when you talk about dosage of chlorine is the demand. How much is the demand plus residual? Why? Because present and safeguard against future contamination both is necessary. Okay. Talking about water softening, already you know. If a water is hard, when you rub it, you won't get foam because they will form precipitate. Why? Because the water contains multivalent cations. I didn't get it. MVS, I have heard it, beta. I will tell you. Wait. What I said, just a minute. Let me complete this chapter, then I'll tell you. Calcium bicarbonate, heat, it will form precipitate. Magnesium bicarbonate, add lime, it will form precipitate. So eventually you will remove it. But permanent hardness, as I already told you, lime soda, zeolite, demineralization you have to do. Okay, coming to the next one. Before that, what I told MVS, where it is there. What I told is when temporal mean velocity gradient means relative velocity. This is one particle, this is one particle. It has velocity v1, this is velocity v2, and this is the distance. So this will be temporal mean velocity gradient will be relative velocity divided by the distance. This will give you the unit of time inverse, that is second inverse. If temporal mean velocity is more and you have provided lesser time for the mixing, okay, lesser detention time, it will be bulky. The flock form will be bulky, but the size will be small. If you have provided smaller temporal mean velocity gradient and larger detention time, the flock will be light, but the quantity will be large. Clear? Which method provides zero hardness? Zeolite methods provide zero hardness. Okay. Coming to distribution conveyance system, let me tell you, haven't asked, but like grid iron system where you use Chandigarh, most planned cities. Dead iron, कोई दिमाग नहीं लगाना, dead iron में lao, connected. Connect from the main pipe is running, you connect all the branch pipes, sub main pipes and all. Okay, old method, grid iron, radial ring are the latest method. Radial system you use wherever there are n number of radial roads, बीच में लगा दो, सब जगह पानी supply, it will be supplied in all the places. Okay. When you talk about methods of distribution, by gravitation, that is water is moving under its own weight. By pumping, by pump you are basically allowing the water to reach at a higher elevation. Generally in India we go for combined gravitational and pumping system. Okay, next, storage capacity, balancing storage. That is, as you know, our demand varies. Like right now you are listening to me, so it might be possible that you are drinking less water, so your demand of water is less. But after this, after the class gets over, your demand will become more. So the demand gets fluctuated. So balancing the variable demand by supplying constant amount of water, that is known as balancing storage. Then breakdown storage, in case of failure of pumps and all, what's amount of water is required, that is breakdown storage. And then comes the fire storage, which is generally 1 LPCD. Okay. Now, if there are any detection of leaks, this points you should remember if they ask you in MCQ for 1 marks. If any leaks are there, you can see mitti gili ho jati hai, that is if unpaved roads and all are there, you can see that the soil becomes wet. Sounding rods you can use, waste detecting meters you can use, you can plot it and you will see whenever there is a kink is there. So you can see that, yeah, there is a leakage going on. So these are the ways which you should know. Okay, then pipe appearances, generally what they can give, two methods are there. One is one side match the following types of walls and another side its function. Next, what they should give is the valve used to regulate the flow of water is, and they will give you 4 options. So that's the thing you should know it. Sluice valve, gate valve, it is used to regulate the flow of water. Okay, you should know the synonyms also. Paryayavachi, which we call, you have to know that. So sluice valve or gate valve is used to regulate the flow of water. Okay, air valve or air inlet valve, or you call it air relief valve. If pressure is less, you allow the air from outside. If pressure is more, you release the air. Okay, so air inlet valve, air relief valve. Reflux valve, check valve, non-returning valve. This you guys would have seen, it's there in pumps. Because we don't want the water to backflow. We want the water to move in one direction only, that is unidirectional, and that is the reason we go for this valve. Then you have scour valve, blow off valve, drain valve. If any sand silt particles are there, you go for that. Okay. Other than that, many other walls are there. Gate valve के आजू बाजू gate valve is always provided at the summit point because the pressure there is less, and air relief and air inlet are also provided at the summit points. Okay, and these are the walls which are also being used till now. They haven't asked you, but at least the names and all you should know. That's it. Okay, these names you should know. That's it. Okay. Coming further to wastewater characteristics. And blow valve and drain valve is provided at the bottom, Rishabh. Okay. Regulate the flow of water. Like Arun, you have seen when we suddenly stop the flow of water black flashes, water hammering effect happens, water hammer effect. Remember? To safeguard against all these things, we go for sluice valve. Clear, Arun? Like it suddenly splashes out. That's the reason for that we go for sluice valve. Clear? Okay. Then coming to the wastewater characteristics, sewage, mixture of waste and liquid waste generated due to various activities. Generated due to domestic activities, domestic sewage, industrial activities, industrial sewage, domestic sewage plus industrial sewage, it becomes sanitary sewage. Sullage is the sewage generated from kitchens and all, that is known as sullage. Okay. Then chemical dissolved oxygen. Dissolved oxygen. Okay, what is the method which we use for measurement of dissolved oxygen? Don't see it here. Winkler's method. I am writing. I don't know whether it is correct or not. You guys will be telling me. This is the correct thing? Arun, Rishabh, you guys tell me. This is the correct? Correct or not? Thumbs up, do it, that's enough. This is correct? Magnesium sulfate, then alkaline sodium. Correct? Yes or no? Tell me fast. दोनों सही लिखा मैंने. देखो यार, तुम लोग सो गए, मुझे पता कैसे चलेगा. वीडियो कॉल में तो बनाया नहीं, तो मैं कुछ भी गलत लिख दूंगी बीच में. वॉच इट. सो गाइस, if MnO2 is produced, then we know that dissolved oxygen is present. If manganese hydroxide is there, then no dissolved oxygen is present. Okay, so this you should know it. Then chemical oxygen demand, the amount of oxygen required for the decomposition of biodegradable as well as non-biodegradable method. Generally, the test is dichromate demand test, which we do it. Okay. Okay. Tell me the indicator used in chemical oxygen demand. Fast. अरे इंजीनियर मैं लिखती हूँ ताकि जो लोग सो रहे हैं ना, ये लोग जाग जाए. Tell me the indicator used in chemical oxygen demand. Tell me fast. मैंने भी नहीं बताना, तुम लोग नहीं बता रहे हो, मैं नहीं बताऊंगी. 2-4 लोग, 2 to 4 people have to answer it. Fastly. Put indicator I am asking. Very good, Risham. Ferroin indicator we use. Hello, Lokesh. Potash dichromate test is there, Amit. Ferroin indicator which we used. Ferrous ammonium sulfate is used for the titration, that is the titrate, and the indicator which we use, that is ferroin. Similarly, the indicator which we used in dissolved oxygen is stars. Beta G, this will all can ask in MSQ questions. So kindly be clear with your concepts. Okay. Then, biochemical oxygen demand, the amount of oxygen required by aerobic microorganisms for the decomposition of biodegradable organic matter, which we call in short as BOD. Okay, standard BOD, we take it as 5 days at 20 degrees Celsius because 2 by 3, or you can call it as 68% of ultimate BOD. 5 days BOD is 68% of the ultimate BOD. Okay, now if you want to calculate for any other temperature, don't worry. Previous questions, they don't used to mention base E or base 10, but in the latest one, they do mention it. So don't worry regarding that. How many MSQ questions are expected? More than 5, I guess. Okay, then 5 days BOD, DO initial minus DO final. If no dilution is done, this will be the answer. But till now, no questions has ever been asked in GATE examination where they don't do dilution. If every question till now asked in GATE examination, they do for dilution. That is, you need to multiply by the dilution factor, which is volume of sewage plus volume of water divided by volume of sewage. Or if it is given in percentage terms, nothing to do, 2% it is given, 100 divided by 2. That's it. Okay, and if they ask you, see, if sample was there, its DO was there. If you added water and when you made it, you combined it, so right now it will become DO mix. So this will be the formula for DO mix: volume of sewage, dissolved oxygen of sewage, volume of water, DO of water. Okay, remember THOD is more than COD, COD is more than BOD. But let me tell you the truth. For all calculation purposes, THOD is approximately equal to COD, but at the back of your mind, you should know that THOD is greater than COD because in theoretical oxygen demand, theoretical hai na? So in pen and paper, you are assuming that 100% decomposition of organic matter is taking place, which in actual is not correct. But assume करने में क्या होता है? Assume करने के लिए मैं भी assume कर लूंगी मैं देश की प्राइम मिनिस्टर हूँ थोड़ी ना. That's the reason. If concentration and type of organic matter is known, you are assuming 100% decomposition of organic matter. That is the reason THOD comes out to be more than COD. Okay. Next, population equivalent. Obviously, as I told you, if industries are there and if you want to collect money from them for disposing their industrial waste, how could I know that in comparison to कितने लोगों के हिसाब का वो क्या कर रहे हैं, सीवेज जनरेट कर रहे हैं, how many times or equivalent to how many people they are generating the sewage. So I go for population equivalent, which is BOD, demand of that industry, okay, divided by per persons per day. What is the BOD? Point सही लिखा है ये 8 kg per day. Is it written correct? Rishabh, Arun, is it written correct? Yes or no, guys? 80 grams per capita per day. So it will be, tell me fast. तो यहाँ पे 0.08 होगा ना फिर तो. Yes or no? You go, guys are like, मैम आप बोलो, हम लोग बिस्तर में आराम से बैठकर सुनेंगे. Is it? No pain, no gain. 80 grams per day. Then talking about relative stability, amount of oxygen, इसमें भी एक चीज है 604, no, it should be 630. 0.08, correct. Relative stability, amount of oxygen divided by required, or basically which is present in the effluent, divided by how much oxygen is required for the decomposition of first stage organic carbonaceous matter. इसको थोड़ा बताते हैं, important. लंच कर रहे, डिनर कर रहे, बोलो भाई. फर्स्ट स्टेज, सेकेंड स्टेज. तुम लोग की क्लास एंड होते तक जोमेटो भी बंद हो जाएगा. देखो मुझे भूख लगा दी अरुण ने. कैसे करते हो यार तुम लोग. हेट्रोट्रॉप्स, ऑटोट्रॉप्स. The amount of oxygen required for the decomposition of carbonaceous organic matter is known as first stage BOD. It is done by heterotrophs. While and they utilizes organic carbon. The amount of oxygen required for the decomposition of nitrogenous organic matter, that is known as second stage BOD or nitrogenous BOD. Decomposition is done by autotrophs, which utilizes inorganic carbon. Okay. And This is the formula. यहाँ पे time है. Time required in days for the decolorization of methylene blue colored solution when incubated for 20 degrees Celsius and 37 degrees Celsius respectively. जितना जल्दी, more the early decolorization, anaerobic decomposition or anaerobic condition reaches earlier, if it is time is less than 4 days, you consider that sample as unstable. Okay. Sewerage system, separate, combined, partially combined. Separate, there is separate pipe for sanitary sewage. Is it? There are two pipes. Ground level water pipe. Okay, water pipe is there. Then separate, you have two different pipes. Two different pipes for what things? Sanitary sewage, there is different pipe, and drainage pipe. So generally sanitary sewage we place it here, and drainage, that is barish ka pani, runoff which you call. You place it at the top. Why? Because drainage water just contains inorganic particles, that is. Okay. Okay. Then talking about combined. Combined, what do we do? Drainage, sanitary mix, do it. Partially combined, or you call it partially separate, because it is not possible कि आपके घर के roofs and all whatsoever water is there, that can also be taken off. So that is the reason the water which is generated is there in your roofs and courtyard and all, that is allowed to get mixed with sanitary sewage. Other than that, all other water is collected in the drainage. So that's the partially separate system. Now this is the designing part. What happens is, if P is the population and X is the per capita water supply. So generally you assume 70 to 80% of the water supplied is converted to wastewater. Remember one thing, again a hook. Some questions they give you water supply is, then you have to multiply by 80%. I have done this in offline and online classes, and maximum students make mistake. Sometimes they confuse you. They will say wastewater supply is, they will write, let us suppose 200 LPCD. And they will also mention, for confusing you, assume 80% of the water supplied is converted into wastewater. And you guys know what? You multiply by 0.80. Why to multiply? When clearly in the question it is written wastewater is 200 LPCD. It is not written raw water. So that is the reason you have to read the question properly. Okay, so the dry weather flow will come out to be 3 times, because we take the fluctuation. If nothing is mentioned in the question, we design for branch. So it is 3 times Q. Next, coming further, stormwater calculations. This is the rational method, 1 by 36 kPCA. PC is the critical rainfall intensity in centimeter per hour. A is the catchment area in hectares. PC is A upon TC plus B. TC is time of concentration, which is inlet time plus channel flow time. Okay. If this time of concentration, and let me tell you, आखरी droplet of water, time taken by the last droplet of water. Let me tell you. This is the catchment area. This is the stream. So time taken by the last droplet of water to reach the outlet, that is known as what? That is known as time of concentration. So PC is 75 TC plus 10. If time of concentration is more than 20 minutes, it is 100 TC plus 20. Okay. Generally in examination, they write it like this, and they give you the value of A and B. Okay. Then Dickens formula, how can you forget? For northern parts of the country, this is the formula for peak discharge. A is in kilometer square, discharge you will get it in meter cube per second. If you forget, ek aur X laga diya. 3 plus 4, 7, alphabets will be 7. 2 plus 3, 5, alphabets will be 5. For northern parts of the country, you use Dickens formula. For southern parts of the country, you go for Rice formula. Okay. Then self-cleansing velocity. Generally, we design the sewer in such a manner that no silting can take place. Certain velocities should be there, that there will be no silting taking place, and the sewer gets clean on its own. Okay. So this is the formula Vs 1 by n r to the power 1 by 6 k. dp is the particle size. Specific gravity minus 1 root half. Okay. This is the part of hydrology. It is the part of environment as well. Jahan pani wahan par ye. Okay, partial characteristics, you know, half flow and full flow, the same hydraulic radius is there, that is d by 4. But it's not necessary that always it will be half flow or full flow. There might be other depth which will be possible. So in those conditions, what will be the ratio of the dia, the area, the velocity, the perimeter, the discharge is being mentioned to you. I'll advise you, study this, remember it, so that you can do it fastly in the examination if it comes, rather than deriving it. Okay, next, coming further. Okay guys, workshop link, which I have already told you, link is in the description, you guys can download it. Okay, these are the important things not being asked, but these are the some things which generally people don't study, and it can be asked. Not much data, but these 2-3 things are the database things which you should know, and this is important, asked in many of the examination. If minimum velocity which is required, it is not satisfied, either increase the slope so that water flows with a high velocity, or increase the diameter. Okay, so this you have to remember. Then equal degree of self cleansing when the shear stress experienced by both the sievers is same. And if you go, this is one of the formula, this is another formula. N is Manning's roughness coefficient. Generally in the examination they assume both of them as same. If in case they don't, that's why I have to. Clear? Clear everybody? इसमें एक चीज उन्होंने गलत लिखी है जो मुझे देख के समझ में आ रही है. V is equal to 1 by n r to the power 2 by 3 s to the power half. So they have written it minus half. 1 by 6 करा. I thought 2 by 3 कर दिया क्या? Fine. Done. Okay. Then coming to disposal of sewage, when treatment से पहले obviously we do for disposal, because treatment से पहले we study disposal. Why? Because where to dispose, based on that we do the treatment. So disposal of sewage, we can do it by dilution, or you can do sewage farming. When you go for dilution, it's that you basically throw the sewage in a water which has multiple number of more discharge as compared to the sewage. Okay, here dilution factor, that is volume of sewage, volume of water divided by volume of sewage, plays an important role. This is not being used right now, but because in the examination it is being asked, you should know this. When dilution factor is more than 500, what are the things you should do? 300 to 500, what are the things you have to do? So this you should know, because they can ask you this in the statement wise questions as well. Okay, next, coming further. Next, coming further, zones of pollution, you know. Zones of pollution: degradation, active decomposition, recovery, clear water. Degradation, the moment you discharge the sewage, water will become dark. The level, if this is deosaturated, the level will go to 40%. 40%. Eventually, at active decomposition, you guys would have seen it, that in the river it becomes blackish in color. That is the zone of active decomposition, because there the water becomes darker and darker, and here fishes die. Algae has already died in the zone of degradation, and the water becomes darker. In recovery, again, maximum amount of decomposition has taken place, almost satisfied. Now the DO level rises. Okay, it tries to reach to deosaturated. Again, one thing, in the zone of recovery, it tries to reach to deosaturated, but it doesn't. It reaches to deosaturated level in the case of clear water. Okay, so these things you should know. Then DO mix, already told you, if sewage is there and river is there. So this will be DO mix. BOD of sewage, BOD of river. When important point, if it is written sewage is heavily polluted or highly polluted, that means DO of sewage is 0. If it is not given in the question and they have written this word, you should know it. Okay, then river is fully saturated with oxygen. If it is fully saturated, means organic matter is not there. If organic matter is not there, BOD of river is 0. So it's not necessary everything they will give you. Sometimes they will write these things so that you can know it. Okay. Then these values, 20, generally we go for 20 degrees Celsius, you know, by Henry's law. As the temperature increases, the solubility of gases in water decreases. So you can say, I'm not talking about liquids. Okay. Then these are the general guidelines which you should know. However, not been asked in examination, but just have a near about idea. That's it. Okay. This equation, guys, study and go. Okay. If you want to calculate the deficiency of dissolved oxygen after T days, Kd is the deoxygenation rate constant, Kr is the reoxygenation rate constant. You have to remember this and go. This is an important formula, that is Tita-Phillips equation. This one, this. Four other things which you need to remember it. Okay, they can ask in the examination. Okay, then coming to, well, you will cover air pollution part. Today only I'll cover after treatment, then solid waste, then air pollution. Okay, now coming to raw sewage part, the treatment of sewage part. Sewage pass through screens, then primary sedimentation tank, and in this we have aeration tank. If we go for activated sludge process, whatsoever sludge gets settled, okay, we take it to sludge thickener. Basically our aim is जितना हो सके पानी को remove कर दो, remove maximum moisture content. That is the reason we go for sludge thickener, and then we go for sludge digestion tank. So this is generally a schematic diagram for you guys. Basically, there are certain mechanisms. First is trickling filter, which is aerobic attached growth mechanism. Aerobic attached growth mechanism, here we carry out the decomposition of organic matter by microorganisms, which utilizes oxygen for sure, and we provide a medium for the attachment of microorganisms. That's why there is the name is attached growth mechanism. Okay. सलाम नमस्कार अहमद जी, अफगानिस्तान से हैं आप, धन्यवाद, थैंक यू. Okay, you will understand English. I forgot. Okay, fine. Welcome, dear. So generally we have two things in trickling filter. This can again be a questions for your theoretical MSQ. Rotary, spray nozzle. Both are the two methods. Generally we go for rotary distribution because sewage is fresh. In the case of spray nozzle method, the sewage is not fresh. So that is the reason we go for this. Okay, then trickling filter, this is the formula for efficiency. In different books you will see different denotation, guys. So that's your Shraddha Bhakti Iksha. What you want, you can take that. Like maximum times I do it like this. U is organic loading rate, which I take it as kg per day per hectare-meter. Basically kg per day is their organic loading rate. Then per hectare-meter is the volume. So U is W by B, which I take it. Okay, generally if some books you will see 100 plus 0.44. This you take when volume is in meter cube. This you take when volume is in hectare-meter. Okay, R by basically two things are there. F is the recirculation factor and R is the recirculation ratio. When standard rate trickling filter is there, R is 0, F will become 1. Okay, and this is the one. Recirculation ratio QR by QD, and recirculation factor, it's not written. 1 plus R upon 1 plus 0.1 R whole square. For high rate trickling filter, recirculation ratio is never 0. Okay, so remember that. That's very much important for you to know. Clear? Here I have taken Li is the influent BOD, Le is the influent BOD. Generally we take it as S0 and S. That depends. If in the examination they give you this diagram and they say Li is the influent and L0 is the effluent, don't be stubborn that we studied S0 and S. What is this? So be flexible with these denotions and all. Okay. Then talking about oxidation point, koi dimag nahi. Sewage, bring the sewage, put it. Water will do all its function. That sewage will flow, it will do all its function. But the only drawback is large areas required 0.5 hectare to 1 hectare. Minimum detention time should be 2 weeks, 14 days. Okay. Depth is 1 to 1.5 meter. One important thing. If they ask you in 1 marks question, guys, you need to remember this. How are the formulas important from? Bilkul important है. If they'll ask you in designing, they will give you the efficiency, they will give you influent and effluent BOD, and they will ask you the volume of the trickling filter. So you need to know the formula. Okay. Now, talking about detention time and oxidation point, 1 upon kT log based in L minus Ly. Generally, we have the habit of influent BOD minus effluent BOD. But why is not effluent BOD? Why is the BOD removed? This thing you maximum time make mistakes. That's the reason it's important. Okay. Now, talking about हिंदी में क्यों नहीं पढ़ा रहे हो? MVS बोल रहे इंग्लिश में क्यों नहीं पढ़ा रहे हो? ये बोल रहे हिंदी में क्यों नहीं पढ़ा रहे हो? एक्टिवेटेड स्लज प्रोसेस. सार्थक, मैंने एक बारी ना हिंदी में भी पढ़ाया है बेटा. मुझे टेलीग्राम में मैसेज करना, मैं आपको भेज दूंगी. ठीक है, इतना मैं कर सकती हूँ आपके. नाउ, talking about activated sludge process, this is based on aerobic suspended growth mechanism. Guys, here we will be the one who will be supplying oxygen, and I have already told you, if you don't provide SST in the case of activated sludge process, it will not function at all. So technically, when you see it in the books also, they write this, they make this as dot, and this is the activated sludge process. This is the system. Okay, so this is the system. Here you need to recirculate the sewage, then only it will function, because initial concentration of microorganisms, if not given in the question, X naught, the microorganisms and the microorganisms which are going, if not mentioned in the question, take it as 0. Okay, next important thing, I'm telling you the facts. In secondary sedimentation tank, some amount of BOD is satisfied, but the calculation becomes tedious, time consuming. So it is our assumption that there is no satisfaction of BOD taking place in SST. That's the reason whatsoever is BOD is going. Here also it is that, here also it is there, everywhere that is the only BOD which is going. There is no removal of BOD taking place after the aeration time. Clear? So this you should know. Then, how can you forget this? Hydraulic retention time, volume by discharge, generally you have to multiply by 24 for getting it in hours. Food to microorganisms ratio, how much food is given? If in 1 liter, S naught is the microorganisms, Q naught into S naught. If X is the microorganisms, in total volume it will be V into X. Okay. Next, organic loading rate, how much BOD is applied to the mass or to the volume of the aeration tank. Sludge age, mass of suspended solids in the system. In the system, V into X. Mass of suspended solids leaving the system. Who are the ones leaving it? Q naught minus QW, it is leaving, and QW is leaving. X. In maximum of the cases, XC value they have not been mentioned, or it is given as 0. But if it is given in the question, you have to consider it. Sludge age is also known by as mean cell residence time. Okay. Then sludge volume index, volume occupied in ml. See, if 1 gram of solid is there and you keep it and you give a time of 30 minutes. So how much volume it will occupy? Mixed liquor means sewage sample. Don't get confused. It means sewage sample. So how much volume that 1 gram of solid will occupy when you allow it to settle for 30 minutes, that is known as sludge volume index. This you take it as ml per gram. Generally it is VOB, ml per liter, XOB, that is the weight of the suspended solids. Since it is in mg, for conversion you multiply by 1000. Okay, so this is sludge volume index. Then talking about the sludge digestion tank, you know here we just break the sludge into 3 forms: digested sludge, supernatant liquor, gases of decomposition. The most dangerous is supernatant liquor because it has a high BOD of 1500 to 3000 ppm. Okay, so we send it again to the PST. Then you have various stages: acid formation, acid fermentation. This is fermentation. Acid regression, alkaline fermentation. So initially acid formers will act. Okay, it will convert it into alcohols and acids of lower molecular weight. Then methane formers will convert it into gases. Gases like methane will be produced. Okay, methane has high calorific value. We can collect it and we can sell it also. And it's like paisa hi paisa hoga babu bhaiya. Okay, then you have capacity, the volume, how much volume is coming minus how much plus how much volume is present in the digested sludge, because the if this is the tank, so here digested sludge some volume will be there, so you will add it divided by 2, because this is linear variation you are taking, divide into retention time, the period for which you are taking for the digestion of the sludge. Remember very important things. If it is given assume parabolic approach, then you have to go through this form. If it is given monsoon storage, means you have to keep certain volume of water for storage purpose also. Okay, certain volume of water for storage purpose means because the digested sludge you cannot put it in the sludge drying beds and all during monsoon season. So you have to keep it stored for the monsoon period. You cannot dispose it. Okay. Septic tank, you guys just know that long detention time 12 to 36 hours. It functions as PST also. It functions as sludge digestion tank also. Okay, why? Because decomposition is also taking place, digestion and all is also taking place. Okay, Hemop tank, 2-story digestion tanks currently, because here sedimentation chamber, settling chambers you have provided, digestion chamber, but nowadays it's obsolete. Clear? So these things you should know. Coming to solid waste management, guys, you know, solid waste, we have talked about liquids. Now talking about solid waste, you have municipal solid waste, industrial waste and hazardous waste, like all the biomedical waste and all also they come under hazardous waste categories. Disposal, just dump it. Sanitary landfilling, proper engineered operation, dumping, then compaction, providing good earth soil, that is landfilling. Pulverization, pulverization is technically not a method. You are just reducing it into lower molecular weight, or you can say you are crushing and grinding it. Composting, what you do, just throw it. There are Bangalore method is there, Indore method is there. Indore is aerobic method, Bangalore is anaerobic method. Generally we go for the twisting is taking place. Generally, we go for Bangalore method because that is an anaerobic method. Okay, you don't have to churn the solid waste again and again. Just basically throw it, or basically proper in a room. You just dump it. Ma'am, how come we will know that disposal has taken place, or basically it has disposal has taken place? In what manner you will see? If this was this much height, after 1.52 months, you will see that the height has been reduced. So this, the volume reduction you will see in terms of the height. Okay, incineration, those waste which will give you high calorific value, you will burn it. Okay, so that is the incineration, but you have to separate those sewage will give you high calorific value, so that you burn it so that you can run that plant with it. This is the formula, that if it is asking you energy in kilojoule per kg on dry basis, 100 minus moisture content. Dry ash free basis, moisture content percentage minus ash percentage. This is the old formula. Right now this formula we don't use. Why? Because in this nitrogen is not being mentioned. Okay, this was the old formula of Dulogs. Right now we don't use it because in this nitrogen is not being mentioned. Okay, now last chapter. Talking about air pollutants. Air pollutants, we have primary. This question, I don't think, as far as I have seen the paper, not even a single paper is there where this question, identify the type of primary pollutant, identify the type of secondary pollutant which has been asked. So classification of air pollutant, primary pollutant, SOx, NOx, radioactive substances, secondary pollutant, H2SO4, ozone, pan, peroxyl acetyl nitrate, this is being used. Okay, you should remember it. अरे नॉलेज अड्डा जी स्वागत है आपका. Okay, now plume behavior. So whenever the gaseous pollutant comes, whatever is the path being followed, we basically study that. That is plume behavior. So here you have super adiabatic lab state. As I told you, you call it as unstable environment also. Why? Before studying this, you should know the meaning of lab state. As the height increases, the temperature of the surrounding air decreases. The rate at which the temperature of the surrounding air decreases with increase in altitude, that is known as environmental lapse rate. Similarly, if you talk about adiabatic lapse rate, as the altitude increases, the temperature of the pollutant decreases with increase in altitude, which is known as adiabatic lapse rate. Okay, if ELR is more than ALR, here mixing takes place, and that is the reason it creates an unstable environment. Okay, if you talk about subadiabatic lapse rate, what happens? ALR is greater than ELR, so this you call it as stable environment. Okay, next. This plumes you should know, guys, because once they have asked this and match the following. Now in different pattern questions which they can ask you is, they can give you the characteristic of it and they will ask you identify the type of plume. Like if they tell you that this plumes occurs in super adiabatic condition, highly unstable environment, produces rapid mixing or loops are being formed, then it becomes very easy that this is a looping plume. Here ELR is greater than ALR. Okay, so if any houses are there, it will be a threat to them. So in this month, then what will be the remedy? You have to increase the height of the chimney in this case. Okay, neutral plume, ALR is equal to ELR, vertical rising will take place. Okay, in the case of neutral plume. Coning plume, here it is stable, ALR will be greater than ELR, and generally you will see cone like this pollutants will be discharged. So the plumes you will see with the, you can say the plumes, the gaseous pollutants, they are being discharged. They are creating a plume like, you can say a plume like shape. Okay. Next, talking about fanning plume. Identify the type of plume which takes place under extreme inversion condition. Fanning plume. Okay, so here it will spread horizontally. Inversion condition means, see, temperature of pollutant will always decrease with increase in altitude, while the temperature of surrounding air, if it increases with increase in altitude, you call it as inversion condition. Okay, ulta ho raha hai, inversion condition. Okay, and if this is happening here, you call it as fanning plume. Clear? Then talking about lofting plume, out of all the plumes, lofting plume is the best and fumigating plume is the worst. So in this what happens? First inversion is there and then super adiabatic condition is there. So pollutants are present above, no threat to us. While in the fumigating it is just the above. Inversion comes afterwards. Is it? Here inversion was first. Getting it? And here inversion comes afterwards. This is correct? Fumigation. This is correct. Diagrams is correct, right? Okay. Trapping plume. The plume get trapped between two layers. Here also this is ALR and this is ELR. 9.8 degrees Celsius is the dry adiabatic lapse rate. That is, if you just, that simple question it is asked every time. If this is from here to here, it is 500 meters. Here if the temperature is 20 degrees Celsius, so what will be the temperature here? Okay, so such sort of questions they can ask you, or they ask you whether it is stable, unstable. So calculate ELR. If it is more than ELR, unstable; less than ELR, stable. Nine. If not anything is given to you in the question, nothing is mentioned, you will take it as 9.8 degrees Celsius per kilometer as the adiabatic lapse rate. Ma'am, why not wet adiabatic lapse rate? Because generally they say above the clouds there is wet adiabatic lapse rate. It's not technically true, but since they take that, that's why we have to consider that. Okay. Then stack height. If you design the chimney height, this is the formula. This is empirical in nature. So if particulate matter is there, this formula you will use. Particulate emission, you will take it in tons per hour. If sulfur dioxide is there, SO2 emission, you will take it in kg per hour. Okay, this values are basically the units, you should know it, important. Next is these are the database not required for you guys. This is one thing which is important. Till now they haven't asked this, but there is one, okay, one weight adiabatic 6 degree, correct. Delta H value, effective height of the stack. This delta H value is given by Holland's equation. So guys, till now they haven't asked, but if like IT professors is like kuch tufani karte hain, so they can ask you. So to be on the safer side, I have provided you with this equation. Okay, so you guys can study this also. Fine. So that's it. And what else you want me to say? In this one more formula is there. This is for the electrostatic precipitator. W is the migration velocity, A is the weight area, Q is the discharge. This is one of the formula again which is being used, and other than that there is no other formulas. Okay. So guys, with this we complete our formulas because it was a formula class. If you want to see the full marathon, so you guys have already seen that, and for next upcoming sessions, I'll provide you with my Telegram group, which I've provided. Fine. So that's it, guys. That's it. Other than that, if you have any queries, feel free to ask me. Thank you everybody for being there, and everybody, Rishabh and all, you have to be present because we cannot, because I'm expecting a good rank from all you guys, so we have to revise the verbal ability portion also because it comes for 5 marks and we cannot dare to even lose a single marks. Okay, so scholarship test, good Arun. Scholarship test link is in the description. You guys can register yourself. It's just free of cost. Okay, so that's all for today. Okay, mine. Good night. I think it's good morning because it's already 12 now. Good morning, everyone, for the next day. So, guys, we'll meet you. Till then, take care of yourself. Bye bye and study hard.